Hey guys, so this morning we're going to look at a aspect of object-oriented programming inside of Python that has to do with classes called inheritance. In the same way that you get your eyes or hair color, facial features from your parents, it's possible to set up classes that can inherit methods and properties from their superclass or their parent class. And the reason that we'd want to do this is because it cuts down a lot of retyping of redundant code. For example, if we stay with the fantasy game kind of theme, then you have a character class and you have a monster class. Obviously, both of those things are different, but both of them share a lot of common features like hit points and armor class and damage and name, things like that. So it's more efficient to write a superclass called entity and put those things that are shared within that class, whether they be properties or methods like attack. Okay, so you put those things into the superclass, the entity class, and then the monster and player class inherit from the entity class. They inherit the things that are common to each other, and then you can add other functionality that's different in them, and it doesn't interfere with what they're inheriting. So what we're going to look at today is a simple case of inheritance, kind of along the lines of a fantasy game class system for characters and monsters. So let's go ahead and look at the desktop. All right, so here we are. So the first thing we're going to do is we're going to establish our entity, class, what you call it. We're going to use our keyword class and give it the name entity. All right, once again, colon, drop down a line and indent. And now we're going to use an initialization method like we did last time. We're going to define, two spaces, init, two spaces, and then we use the keyword self. Now what this keyword self does, let's talk about a bit about this. I don't know if I went into enough detail. The keyword self tells Python that the methods and the properties anyway, that are being established here are for specifically this object. Okay, so if we build an object from this class, the object will have its own set of properties, and that's what the self words stand for. If we don't put that in there, then the properties that we establish will be class-wide, which means any object that we build with this class will have exactly the same properties, and that won't work because sometimes different characters need different numbers of hit points, for example, or different armor classes. So if we don't use the keyword self, then what happens is we are unable to assign different values to the properties that we're setting up here. But we're going to use the keyword self, and the things that are going to be in common we're going to establish as properties. In this case, we're going to use name, because everything in the game has a name, whether it's a monster or character or whatever, NPC. Regardless, it needs a name. And then let's see, what else can we put as a... could we do something like character class? Let's look at a little object-oriented principles here. Character class is going to be more specific to a character. Now, we could put that in there, and sometimes, in however you design your game, maybe that monsters have classes. But for the most part, the only entities that have classes in these games are characters. They have fighters and wizards and clerics and whatnot. So character class seemingly would be more specific to the character class and the character object and not so much to the monster object. Remember, we're trying to find things that both or all the different types of entities within the game would inherit or would need to inherit. So we know that everything needs a name. Everything in the game is probably going to do some kind of damage, or at least monsters and players will. So let's go ahead and do damage instead of character class. And we'll save character class for the character itself. All right, once again, colon, drop down, indent. And we're going to establish the parameters. Once again, we use the keyword self. And we're going to say self.name. The parameter name is equal to the temporary variable name that we put up in the parentheses. And we're going to say self.damage is equal to the temporary variable we put up there called damage. What we're doing is we're saying this property of the class or the object is equal to this temporary variable, and we're going to pass these in when we build the object. All right, so we've got a couple of properties. Let's give it a method. Let's give it an established method. So we're going to define a method. And we're going to make it say my name. So we're going to make it say its name. We're going to use the keyword self again because we don't want it to be, we don't want all our players or all our monsters to all have the same name. That wouldn't work. Colon, drop down a line, tab. Get used to doing that. Anytime you're defining something or building something, colon at the end, drop down a line and tab over. Now we're going to give it a print statement. My name is plus self.name. Okay. So now we have a method. Anytime we ask it, it'll say its name. All right, so we've done that. This is actually our next class. Let's make a class that inherits from the entity class, and we're going to call it player. To go to colon. Oops. We need to have it inherit though, so we put it inside parentheses like this. Now we can do that. So basically what we're saying is this player is a subclass of entity. So all the stuff that we have in here, all the code that we have for entity, we can also use in the player class. And so once we've established our subclass, we're just going to leave it empty, but colon, and we're going to use the pass keyword because we're not going to put anything in here right now. We're just going to leave it empty. Let's go ahead and make another one, and we're going to call this monster. And it also will inherit an entity, and we're going to leave it empty. So there's no code built into any of our subclasses. The only code is in our superclass. Now let's establish in our regular code, this is actually our program, let's go ahead and build some things. So we're going to say equal to player name the awful. Okay, damage 5. Oops, 5. Alright, so we built a player named Olaf the Awful who does 5 points of damage. And we're going to make him say his name. Oops. Say my name. We called his method. Now we're going to build a monster. Work is equal to monster. Grabhook the Grievous. And he does 2 points of damage, so. Alright. And now work dot. And we're going to have him say his name as well. Okay, so let's go ahead and first of all, let's open up our command prompt. Change to our Python code folder. Make sure that we've got, we've saved this as exercise 16, and there it is. So let's go ahead and run exercise 16. And sure enough, it worked. So we built a character named Olaf the Awful, and we had him say his name. Whoops, what the heck? Did I not save that? Let's try that again. Let's try that again. I think I had an old code in there. Let's try it one more time. That's what I wanted to see. All right. So, we built a player character named Olaf the Awful, and we built a monster named Grabhook the Grievous. So now we've inherited from our entity class all this code because we know there's no code in here at all. There's nothing in the player or monster class to make it do anything. All the functional code is up here in the superclass. So inheritance works. We've established that. Now what we want to do is add some specific functionality to our monster and to our player so that we can say, all right, monsters and characters need to do different things. So we're going to go ahead and add some stuff to the player class first. And to do that, we need to establish our own init method for the player. So we're going to define an init method here. And we're going to use the self keyword again. We're going to keep the name and damage, but this time we're going to add a character class. Okay? Colon, drop down, parentheses. All right, now this is where it gets different. In order to keep the information from above, we need to use the super keyword here. And that lets us inherit that lets us keep inheriting all the stuff from the entity class, even though we're adding a new init method. So we're going to use the super keyword, dot, and we're going to add, init. And what we're doing is we're copying the init from above, but we're not going to use the self keyword. We're just going to do name and damage. Okay, so we've called that. That's just a method call. We're not defining anything here, so we don't have to do a colon and drop down anything like that. So we're going to keep all this information up here, but we're also going to add a character class. Use the self keyword. This self is the same as this self. And we're going to say dot character class is equal to character class. Okay. So now, when we call our our player class, we have to add another parameter down here. We have to add a class. Make him a fighter. So, and we need to add another method because now we need to be able to tell the world what he is. So we're going to let's define. Say my class and self. We're defining, so there's that. And print a plus self dot character class. All right. So now our player has two methods and a new property. Monster is still just inheriting from the entity class. So now we got to come down here, and since we have three things that we need to add to our player when we're creating him. Remember, this self is just a keyword, but we have three things we have to add, so we had to change our call here to make our player name, damage, and now class. Name, damage, and class. So now let's go over to our environment. Did I save that? Make sure we saved it. If you don't save it, yeah, there you go. That's not I didn't ever tell player one to say his class. There we go. Not bad. All right. Attention to detail. That is the key. Okay. It worked, finally. So we got the first line. We have him say his name. Name is Olaf the Awful. And a class, I am a fighter. And of course, Grabhook the Grievous is still saying his thing down here. But what we did was we added the third parameter, class, and then we called the first and we called the second method. Now, if we try to do that with monster dot say my class, we are going to have a problem. Nope, can't do it because monster object doesn't have a same class. It doesn't have a method that allows it to do that. There's no place to put a class in there. There's no character class. So we can only use things that are in the subclasses in the subclass objects. We can't inherit subclass unless we want to make multiple levels of inheritance, which is possible, but it gets very confusing after a while. You've got a superclass, and then 2 classes under that, and then 4 classes under them, and each of those has 2 classes, and pretty soon your classes are all twisted up into a big tree, and it's a lot of trouble. So definitely not a thing that you would want to try to involve yourself. So 2 levels of inheritance is usually enough. If you need more levels than that, then you need to look at another solution. There are better ways to design your program and to organize your inheritance than having multiple levels. 2 levels is usually plenty. So we've got 1 level here and 2 levels here. All right, so basically that is inheritance. We can add functionality to our subclasses that is not shared between the 2, but we can add functionality to our superclass that is indeed shared and that both subclasses can use. Okay guys, I hope this was helpful. We're going to go and look at more inheritance and some different parts of inheritance that we looked at. This is just kind of an introduction, but I don't want this video to run on forever. So let's go ahead and get on with the exercise. When you're done, you have the code working. Use the submit button above and then turn in your work. And if you have any questions, contact me through the Canvas inbox, or you can come up to the 2nd floor of the library by the back stairs, room 210. It's the one that says Canvas Help Desk. I will be happy to answer your questions. In the meantime, have a good day. Hope to see you in class.